So students, look at this triangle. Before we took the angle and the sides joining the angle, that means this side and this side. That's what we did the last time. But instead of taking those two sides, what we will do is we will take the other two sides. Okay, so we are not taking the angle between them, we are taking this angle. We are taking the angle outside those two sides. So we are taking this angle. Okay, so two sides and the angle out, and we are going to check whether if it is a valid condition for congruency or not. So to check that, what we will do is we will just move this triangle here, and what we are going to consider is these two sides and this yellow angle, these two sides and this yellow angle. Okay, so because these two sides we cannot change, that need to be same. That is our check. We are going to check if that works. So I'll bring this side like this. Okay, I'm not changing the length, I'm not changing the angle. Okay, now because there is an angle like this, some line has to come like this, right? I mean okay, this is not right. Some line has to pass like this, right? Okay, my drawing is not that good here, so I will tell the animation to do that. Some line has to pass, right? Now this line is, I can make it shorter or even I can make it longer, it doesn't matter, because this line is not what we are considering. We're only checking these two sides. Okay, now let me just rub that off. Okay, now I'll bring this side. That side has the length. I cannot change the length of that side because that is the side that we're checking. Okay, but this angle I am not considering. I'm only considering this angle. So because of that, I can actually change that angle. Without changing the length, I'm going to change that angle. Do you see that? I have not changed the length, I only changed the angle. Now I'm going to bring that length down, bringing that side without changing the length. I brought that side down. So actually this side is equal to this side, and this side is equal to this side. Do you see that? And this angle is equal to this angle. Okay, now to make it a proper triangle, I'm just rubbing that part off. I can rub it off because that side we are not considering. Now, are these two triangles congruent? No, of course not. Both are different shapes. Leave the size. Both are different. Both are arranged in a different way. Both triangles are in a different shape. So, because of that, SAS used to work, but SA, when the angle is outside the sides, not between the sides but outside the sides that we are considering, it will not work. It is not a test for congruence. Okay, but there is one triangle where it might work. Look at the right triangle. Okay, let me just rub that off. Look at this right triangle. This is a right triangle. Now, you know what is the specialty of a right triangle? The hypotenuse. Hypotenuse is the side opposite the 90 degree. So the hypotenuse, the square of the hypotenuse is equal to the square of the other two sides. That is a property of right triangle. Now, because of this property, we can check SSA. That means two sides and the angle that is not included. Okay, so like what we did previously, I'm going to bring those sides like this. So this I'm not changing the length. This length is equal to this length, and of course we see that it is both are 90 degree. So because this is 90 degrees, some line has to go like this. Oh, I drew that nicely. Okay, some line has to go like that. So because of that, I will draw a line. I'll bring that line. This length I can change if I want, but because we are not considering that side. Okay, but now to make this a triangle I need one more line, and I need this line should to be the same, because that is what we are checking. So if I'm bringing that side, tada, it becomes like this. Now there is no way that I can change it, because if I make this side like this, if I change it, then this length will change. Do you see that? This length will change, and so this thing will go. So that will become a problem. So there is no way that I can actually change that. So the only way to connect the third side is to do like this. So we see that in RHS it is congruent. What is RHS? Right triangle. So in the right triangle it is congruent, and we cannot stop that. Or even though in the other triangles it is not congruent, in these two triangles it is congruent. So SSA sides and the angle not included, some other angle outside. But SSA is a very general term, because we cannot use this for all triangles. We can only use this for right triangles to prove congruency. So, and one angle is 90 degree, and if it is a right triangle, of course one angle has to become 90 degree. So this angle, since it is 90 degree, I will change the A and I will make it R, which denotes which signifies right angle. And one of these sides has to become the hypotenuse. Do you see that? One of these two sides has to become the hypotenuse, because if I take this side, then it becomes the angle between those two sides. So I cannot take this side. So one of the sides has to become the hypotenuse. So because of that, one side I will make it H, which means hypotenuse. The other one is a side. It can be either this side or this side, any side. So I have the right angle, the hypotenuse, and the side. But SHR doesn't sound good. SHR doesn't sound good. So I will just reverse it. I'll put the H here and just put the S here, and we get RHS. That sounds a little more nice. So RHS. R stands for right angle, H stands for hypotenuse, S stands for side. It could be any of the other two sides. Now students, listen to me really carefully. The reason why it works is because in a right triangle, the hypotenuse is based on the other two sides. You get it? The hypotenuse is based on this side and this side. The square of the hypotenuse is equal to square of the other sum of the squares of the other two sides. Or it is because of that SSA or RHS is valid only for right triangles. Okay, so that's enough for this video. The next video we will look at another test.